Good morning, Ma. Good morning to all of you. So today, last class, we have studied about the problem in which it has been given to find the stoichiometric coefficients. 2/3 of the substrate carbon has been converted to biomass. Like that, a problem has been given and we have solved that problem and found the stoichiometric coefficient as well as yield coefficient as well as the degree of reduction and respiratory quotient and all. Okay. So the next problem is estimate the theoretical growth and product formation, that is yield coefficient for ethanol fermentation. So they have given the equation and they have given, this is the given data. Okay, y of x by ATP is equal to 10.5 grams of dry weight of cells by moles of ATP. Okay, this is what they have been given. Okay, this is what the data they have given, that is 1 minute. This problem is not required. Okay, we will see last. If there is time, we will see that. Otherwise, we will go ahead with the next problem. Okay. Okay, so the next problem is the growth of Saccharomyces cerevisiae. That problem is not required, ma. This problem is not required. The next only the stoichiometric coefficient problems is there. So the problem is the growth of Saccharomyces cerevisiae on glucose under anaerobic conditions can be described by C6H12O6 plus beta NH3 gives 0.59 CH 1.74 NO2 0.45 0.43 C3H8O3 plus 1.54 CO2 plus 1.3 C2H5OH plus 0.036 H2O. And you remember all these questions, the equations you people should study. Okay, sometimes they will ask find the stoichiometric coefficient for the equation of growth of Saccharomyces cerevisiae. Okay, on glucose, like that they will ask. So for that, what you have to do means you have to know the equation. So always study the equation. So what they have asked here is determine the biomass yield coefficient y x bar s and determine the product yield coefficient, that is y ethanol by s, y CO2 by s, y C3H8O3 by s, and determine beta. Okay. And for this problem, almost all the coefficients has been given, that is 0.59, 0.43, 1.54, 1.3 and 0.036. So these coefficients has been given. Only thing is we have to find beta. They have asked us beta. And parallelly, we have to find yield coefficient, that is y x bar s. That means biomass divided by substrate. So if this is the biomass, then this will be the substrate always. Okay. So biomass by s and then ethanol by s. Okay. So ethanol C2H5OH by s and then CO2 by s. Okay. Uh, where is CO2? CO2 by S and then C3H8O3 by S. All this you have to find. Okay. So now biomass is y x of S is equal to molecular weight of biomass by molecular weight of substrate. Okay. So how you can do this is, so first what we can do here, we will find all the values and then parallelly we will do. Okay. So here this is little confusing for you people. Whatever I have written here, I will just show you how you can find. Okay, so first is y x bar s we have to find. So y x bar s is what we have to find, and same way y ethanol by s and all they have asked. So what is the biomass here is x is biomass, right? So first let us find for that 0.59. Okay, so biomass is 0.59 CH 1.74 N 0.2 O 0.45. Okay, O 0.45. So this is how the equation. First, what you have to find? You have to find the values. How will you find 0.59 into, okay, so 1 into 12. So this 0.59, don't forget 1 into 12. plus 1.74 into 1. Okay, 1.74 into 1 plus 0.2 into 14 plus 0.45 into 16. Okay, same way you have to find for all the things and then you can substitute. Okay, so you have to find the answer. Okay, for this how it will come. So now I will go back to that. You people know x bar s how we have to find. Okay, so now here first we have found for biomass. Okay, that is 12.1.74 into 1.2 into 14 plus 0.4 into 16 into 0.59. You will get the answer. Then first find for C2H5OH. Okay, that is 4 into 1.3. So you will get 59.8. Same way you have found for C3H8O3 and then what? So same way we have found everything. And then for substrate that is C6H12O6 180. Now find y x bar s, okay, and then find y ethanol by s, y CO2 by s, y C3H8O3 by s. Okay, either you can find this way and substitute, or directly also you can find only the substrate value and then you can substitute, find the values. This is just substituting the values and finding the answer. That is accordingly. X is biomass, substrate is what? Whatever that is the C6H12O6, same way ethanol by substrate, CO2 by substrate, C3H8O3 by substrate. Okay, and what you should remember here is you should substitute the coefficients also. You should not forget to multiply with that. Okay, that's all this problem is all about. And the next problem is we have to find the beta. Okay, so for beta we will see here. Okay, beta NH3. So out of this nitrogen and hydrogen, nitrogen is having less amount. So if you do the nitrogen balance, you will get the answer easily. Okay, so you have nitrogen and hydrogen. So out of this, if you do either nitrogen balance also, you will get the beta value. If you do the hydrogen balance also, you will get the beta. Out of that, nitrogen is simple, so we will take the nitrogen. Okay, so when you do the nitrogen values, you will get 1 into, okay, beta into 1 into 14 is equal to 0.59 into 0.8 into 14. Okay, zero point 0.9 into 0.2 into 14. So directly you will get the beta value. Okay, this is all about this problem. And the next is, okay, say, aerobic growth of Saccharomyces cerevisiae on ethanol is described by C2H5OH plus AO2 plus BNH3 gives C of CH 1.704, N 0.149, O 0.408 plus DCO2 plus EH2O. And determine, they have what they have asked is ABCD. Okay, we have to find ABCD, where respiratory quotient is being given as 0.66. They have given previous problem, they have given 2 by 3rd of the substrate. So here they have given the respiratory quotient value is 0.66. As parallelly, we have to find y x bar s and y x bar O2. As you people know, first let us see what is the given data. Respiratory quotient is being given, that is moles of CO2 produced by moles of oxygen consumed. That is D by A is equal to 0.66. So that can be written as D is equal to 0.66A. Okay, till this point is clear. So same as like previous problem, they have asked us to find the stoichiometric coefficient. But what is being given here is respiratory quotient is being given. Instead of the 2 by 3rd of the substrate carbon is converted to biomass, here respiratory quotient is being given. So the respiratory quotient is moles of CO2 produced by moles of oxygen consumed. So moles of CO2 produced here is D, moles of oxygen consumed here is A, that is D by A is equal to 0.66. So D is equal to 0.66A. So this is what the first equation. Now, since nothing else is being known, so none of the coefficient also is been found. So we have to start from the carbon balance, like carbon balance, hydrogen balance, oxygen balance, like that. Okay. So now carbon balance will be what? 2 into 12. That is 1 into 2 into 12. Okay. Don't forget that. Okay. So 1 into 2 into 12. Here nowhere else carbon. So here C into 1 into 12. Okay. So always you people don't forget to write the 1 ma, otherwise you will get mixed. C into 1 into 12, and next is here plus D into 1 into 12. Okay, D into 1 into 12. So you have got the equation 2 is equal to C plus D. Okay, and the next is we have to go for hydrogen balance. Okay, so hydrogen balance, again the equation is, what the equation will be here. Okay, 1 into 5 into 1 plus B into 3 into 1 is equal to C into 1.704 into 1 plus E into 2 into 1. Yes or no? So you will get 6 into 1. So you will get the equation as 6 plus 3B is equal to 1.704 C plus 2E. And the next is oxygen balance. So oxygen balance, again, how will you write? 1 into 1 into 16 plus A into 2 into 16 plus C into 0.408 into 16 plus D into 2 into 16 plus E into 1 into 16. So you will get a bigger equation. So you will get as 2A plus 1 is equal to 0.408C plus 2D plus E. So you will get an equation. So out of this, any equations you cannot find any value. So we have to first write all the balance and then you have to find. The last one is nitrogen balance. So B into 1 into 14 is equal to C into 0.149 into 14. So you will get the equation. Okay, so that is 1.257C plus 2C plus E is equal to 6. So now nothing else. We have to do the substitutions, something we should do and find the answer. So first what we will do means, we will substitute this first equation in fourth equation, so that what happens here is this B can be converted into A. So substitute 1 in 4. So you will get, after substituting and solving, you will get 0.408C plus E minus 0.68A is equal to 1. Now this is the seventh equation. Now take 6 and 7 and subtract. Okay, so sixth equation is 1.257 plus 2E is equal to 6. Now multiply 7 with 2 and subtract it. So what will happen? This E will can get cancelled. Okay. So now 7 into 2. First 7 into 2. So you will get 0.816C plus 2E minus 1.36A into 2 minus equation 6. That is 1.257C plus 2E is equal to 6. So when you subtract this, you will get 0.441C plus 1.36A is equal to 4. Okay, this is equation 8. Now again what we are doing is substituting equation 1 in 2. Okay, substituting equation 1 in 2. Just go through the steps, ma. So substituting equation 1 in 2. So you will get equation C plus 0.66A is equal to 2. Okay, C plus 0.66A is equal to 2. Now you will take this 8th equation and 9th equation. Okay, so 9th equation into 0.441C. Okay, so you will get this minus equation 8. So you will get the value A. Okay, so once you get one value, finding the other values will be easy. So D by A is 0.66. So you will get the D. And then you take equation 2, substitute the D value, you will get the C value. And then you take equation 5, substitute the C value, you will get the B value. Same way you will get the E values. Okay, so remember, so this problem will be of this method only. The values will not change, anything will change. So there's this aerobic growth of Saccharomyces cerevisiae means only this equation will be there. So whoever cannot remember the steps, just try to remember the steps. In this way only we have to do, because this problem will come only in this way. So we have written the D by A, respiratory quotient, and then we have written the equations what we get according to carbon balance, hydrogen balance, oxygen balance, and nitrogen balance. Okay, and then just substitution cancelling we have done. Just to go through this problem so you will understand. Okay, substitute cancel, that is what we have done. Okay, so now A is equal to 2.916. So we will get the stoichiometric coefficients. Okay, so once stoichiometric coefficient is done, next what they have asked is y x bar s. So that is biomass by substrate. Okay, this is the biomass value and this is the substrate value. Substitute y x bar s. So you will get this is the C value, that is 0.075. Okay, into 22.7378. So you will get the answer. Same way they have asked y x bar O2 also. Same way, find x value is known already. So just write the O2 value. Okay, you will get the answer. So here they have asked the substrate yes. Here they have asked us the O2 value. I hope this is nothing else, just the substitution and solving. So if you do the balances correctly, balancing the carbon, nitrogen, hydrogen, oxygen, all the other things you can do it easily. Okay, and don't just listen it. All of you, please try solving it. Okay, this substitution and all you have to solve it, then only you will understand. Okay, and the next problem of this or the last problem of this module is aerobic degradation of benzoic acid by a mixed culture of microorganisms is given by, okay, C6H5COOH plus AO2 plus BNH3 gives C5H7NO2 plus BH2O plus ECO2, and this is the biomass and this is the substrate. So they have asked determine the ABCDE if RQ is 0.9. Again they have given the respiratory question. Determine the yield coefficients, that is y x bar s and y x bar O2, and then they have asked us the degree of reduction for substrate as well as the biomass. This is the biomass and this is substrate. They have asked us to find the degree of reduction. So first, what is being given is respiratory quotient. So respiratory quotient is moles of CO2 produced by moles of O2 consumed. So moles of CO2 produced is E, O2 consumed is A. So E by A is equal to 0.9, that is E is equal to 0.9 A. That is the first equation. This is the same method, okay, of previous problem. Next we have to go for carbon balance. Carbon balance will be 1 into 6 into 12. Into plus 1, that is 7. Okay, so you will have 7 into 12 plus what, sorry, nothing, is equal to 5 into C into 12 plus E into 1 into 12. Okay, so we have cancelled all 12, so you will get 7 is equal to 5C plus E. Actually you will get 7 into 1 into 12 here. See here. Okay, so here you have 1, so 7. Okay, 7 C's. So how will you write here is 7 into 1 into 12 and then 5 into C into 12. Okay, plus E into 1 into 12. So what happened here is we have cancelled all 12 and we have written as 7 is equal to 5C plus E. This is how we have written. Okay, so nitrogen balance also same way we have written, because so that the equation will be easy. Okay, nitrogen balance is B into 1 into 14 is equal to, because very less, so C into 7 into 14, so B is equal to 7C. We have written as what, B is equal to C, 7 is equal to, so it will get cancelled. Okay, so you will get B is equal to, sorry, B is equal to C, that is 1 into C into 14, B into 1 into 14. Same way you have to write for oxygen balance and hydrogen balance. You will get the equation 2 plus 2A is equal to 2C plus D plus 2E. And hydrogen balance is 6 plus 3B is equal to 7C plus 2D. So nitrogen balance we have got B is equal to C. Substitute here. So you will get 6 minus 4B minus 2D is equal to, instead of C, you substitute B. Okay. Instead of C here, you substitute B. So you will get 4B plus 2D is equal to 6. Now what we have to do, substitute 1 in 2. Okay, that is E is equal to 0.99A. So this equation also will be converted in C and A form. Okay, so substitute 1 in 2, you will get 7 is equal to 5C plus 0.9A. Okay, so now take the equation 3, that is B minus C is equal to 0. So now to compare this equation 7 and 3, that is 3 into 5. 7 equation is 5C plus 0.9A is equal to 7. Third equation you multiply with 5. So you will get 5b minus 5c is equal to 0. So this cc will get cancelled. So you will get 0.9a plus 5b is equal to 7. And then now take equation 4. Okay. So 2 plus 2a is equal to 2c plus 2d plus 2e. So instead of e, you substitute 0.9a. Okay. So after solving, you will get 2b plus d minus 0.2a is equal to 2. Now take equation 6 and 9. Okay, this equation and this ninth equation. So you will get 4b plus 2d minus 0.4a is equal to 4. So ninth equation into 2 minus sixth equation. So minus 0.4a is equal to minus 2. So you will get a. So once you get one value, so the remaining value finding is easy. Okay. So substitute this a is equal to 5 in equation 1, you will get e. And then what, again equation substitute a is equal to 5 in 8, so you will get b and you will get c also. Parallelly you find all the stoichiometric coefficients. Okay, this is just like the previous method, just you have to find the value, substitute in the equation and find the stoichiometric coefficients. You just go through and solve the problem, you will understand very clearly, nothing else, just solving it. Okay, write the balancing and solving it. That's why I'm not explaining in very detail. So if you just go through, you will understand. Okay, so what you have to do means you have to write the balancing and then what, substituting and solving all the equations and find the stoichiometric coefficients. Okay, so once you have found the stoichiometric coefficient, and the next part is they have asked us to find the y x bar s. Find x value, y s value. Okay, so here they have done little differently. So the coefficients they have multiplied at last. But what you people do is like how I have explained in the first problem, include it in the beginning only. So it will be easy. Y x bar s and y x bar O2, it's been found. So the answer will be like this. And the next is degree of reduction for substrate and for what? Bacteria. So you will have, okay, so substrate is C6H5COOH only. So there is nothing else, coefficients is not there. Okay, so you have to take directly C6H5OH. Okay, so degree of reduction is C6H5OH, that is 6 into 4. Okay, 6 into 4 plus 5 into 1 plus 1 into 4 plus 2 oxygen, 2 into minus 2 plus 1 into 1. Okay, so now you will get 30 by 7 is equal to, so total carbon atoms is 7. So 30 by 7, so you will get 4.28. Okay, so the next is alpha b, gamma b, that is 5 into 4 plus 7 into 1 plus 1 into minus 3 plus 2 into minus 2. Okay, and then the coefficient is 20. So 20 into 0.5 divided by 20 into 0.5 by 5, that is 2. So these two problems, the previous problem and this problem is of the same method. Okay, only here you should not substitute the coefficient, sorry, atomic weight. Remember, degree of reduction should be of what? The small elemental. Okay, balance. So the next problem is simple problem, next method. So you will have three types. One is they will be given the substrate carbon converted to biomass, and the next is they will be giving the respiratory quotient and they will ask us to find the stoichiometric coefficient. And the next method is they will give y x of s value and you will ask us to find. So the aerobic degradation of an organic acid production by a mixed culture of organisms in wastewater is represented by C3H6O3 plus AO2 plus BNH3 gives C5H7NO2 plus DH2O plus ECO2. So here we have to determine A, B, C, D, E. If Y x of S is 0.49 into 0.4, okay, this is not 0.49, 0.4 gram of X by gram of substrate. So here they have given Y x of S value. And then we have determined Y x of X bar O2 and Y x bar NH3, and also we have to determine gamma b, gamma s and respiratory quotient. So this is what we have to find. Okay, so first they have given is y x bar s. Okay, so x bar s is molecular weight of biomass by molecular weight of substrate. So X bar S is been given as 0.4, that is C into molecular weight of biomass divided by molecular weight of substrate. So biomass is C5H7NO2. Okay, that is 113. So here coefficient is there. For substrate, there is no coefficient. So 90. So 0.4 is equal to C into 113 by 90. So in the beginning only, we have got one coefficient value. So if you get the coefficient value, it is very easy to solve the other, find the other values. So now let us go for the carbon balance. Okay, carbon balance is 3 is equal to 5C plus E. Okay, so and then you have to find the oxygen balance. So the equation is 3 plus 2A is equal to 2 into 0.31285 plus 2.363 plus 2 into 1.407. You will get the equation. Okay, same way. And then when you do the nitrogen balance, you will get the B value also. Okay, because B is equal to C. Okay, so you will get B is equal to C, you will get the B value. And when you go for hydrogen value, you will get the D value. Okay, so similarly, you will find the substitute the D value here, you will get the EA value. Same way, you will get all the values. Okay, so do the problem and get the stoichiometric coefficients A, B, C, D, E. Okay, it's nothing but just first in the beginning only you know the value, and then you have to write these carbon balance, oxygen balance, nitrogen balance, everything. So one balance, you will get the values. Okay, substitute the values and find it. So, and you people know why X bar O2 find it, why X bar NH3 find it. So this is what the answer 0.799 and 6.65. Okay, 0.77, 0.799 and 6.65, and then find the degree of reduction of substrate, that is C3H6O3. So 3 into 4 plus 6 into 1 plus 3 into minus 2, that is 12, divided by gram atom of carbon, that is 3, 4. And for biomass, you have to find C5H7NO2 and you have a coefficient. So that coefficient is what is been given into 0.3185. 5 into 4 plus 7 into 1 plus 1 into minus 3 plus 2 into minus 2. Okay. So you will get 1.27, and they have asked us to find the respiratory quotient also. That is E by A. 1 point E and A value both are same. So you will get the answer as 1. So this is nothing. The stoichiometry coefficient is nothing but you have to write the balance and then you have to solve the equations, find the stoichiometry coefficients, and then while finding the yield coefficients, don't forget to put the coefficients, that is the moles, A, B, C, D values. Okay, so that is the only point you people should remember very clearly. So for this, only these many problems in the module 5. So first, for conversion of 2 by 3 of substrate, you have two problems. And the next is respiratory quotient value is being given. For that method, two problems. And the respiratory quotient method, it is easy, but what you have to do means you have to solve the equations. So the equation solving will be little more. You people just practice so that you will get the equations easily. While looking, it will be seems to be little difficult, but when you write and practice, it will be easy. Okay, and the next method is they will give the yield coefficients and they will ask us to find the stoichiometric coefficients. So three different methods. So this module has only these many problems. Okay, so if you have any doubts, you people can ask ma.